Today we're going to be graphing exponential functions, but as opposed to what we did the other day, we're going to be shifting our graphs left, right, up, or down. So we're not going to do this warm up because there's no shifting in this one right here. But down here in number 2, we are going to graph this. We do have some shifting. We have an h and k value here. So what I want to do first is kind of to outline, all right, that -2 means that we're going to be moving right 2. And this +1 means we're going to be moving up 1. So we're going to do the exact same steps as we did when we didn't shift these functions. And we're going to plot our graph without the shift. And then we're going to take each point and shift it right 2 and up 1. So we're going to make an XY table. And our X values, -2, -1, 0, 1, 2. And the value right here of 3, okay, that's going to tell us what we're going to be multiplying by. So we have 0, 1 on the graph, and then we're going to be multiplying by 3. So 1 times 3 is 3, 3 times 3 is 9. And then backwards, it'll be 1/3 and 1/9. So then we'll do our third row. And in our third row, we'll multiply everything, all the y values, by 1/3. So 1/9 times 1/3 is 1/27. 1/3 times 1/3 is 1/9. 1 times 1/3 is 1/3. 3 times 1/3 is 1. And 9 times 1/3 is 3. So we'll cross off that middle row. And we'll plot these points. -2, -2, 1/27. So that's going to be really close to 0. So let's put a dot right above it. -1, 1/9. Again, pretty close to 0. 0, 1/3. 1, 1. And 2, 3. So here is our graph without any shifts. But now we're going to take each point and go right 2 and up 1. So right 2, up 1. Right 2 and up 1. Right 2 and up 1. Right 2 and up 1. And right 2 and up 1. So now our graph looks like this. So now based on that red graph, we can answer the questions. This is exponential growth because our A value is a positive number and our B value is bigger than 1. The domain for exponential functions is always -infinity, infinity. Now the range, without shifting upwards, if we were looking just at that blue graph, you would say that all the y values are bigger than 0. That y = 0 would be our horizontal asymptote. We would always have our y values bigger than that, and we would approach y = 0. But now we are shifted up 1, so all the y values are shifted up 1. That means your asymptote is also shifted up 1. So that means your range would be 1, infinity, because the y values are going up. Your horizontal asymptote is y = 1. And your end behavior, as x approaches -infinity, that's for the left side. And as x approaches positive infinity, that's for the right side. So if you look at that red graph, the right side's going up. The left side is approaching our asymptote. So the left side as x approaches negative infinity, y approaches 1. And as x approaches positive infinity, that right side is going up. And that's going towards positive infinity. So you'll notice that the range, the asymptote, and one of the end behaviors all line up. They all match, just like they did when we weren't shifting. They were all 0 at that point, but now that we're shifting up and down, that will affect our range, our horizontal asymptote, and our end behavior. All right, let's look at the next page. Here, we don't have a vertical shift. We don't see any plus or minus out here hanging out. So we just have this +3, which means we are shifted left 3. So we'll make our table x and y. And our x values, -2, -1, 0, 1, and 2. And, our b value is 1/2. So we'll start at 0, 1, and then we're multiplying by 1/2. That's our growth rate. So 1 times 1/2 is 1/2. 1/2 times 1/2 is 1/4. And then going backwards, this will be, you could write this as 2/1 or just 2. And you could write this one as 4/1 or just 4. So then we'll get our third row here. And we're going to multiply everything by -8. So 4 times -8 is -32. 2 times -8 is -16. 1 times -8 is -8. 1/2 times -8 is -4. And 1/4 times -8 is -2. So we can go ahead and plot this. Again, we're going to cross off that middle row. So -2, -32. Yeah, that's going to be quite a ways off the graph. I understand that. So it's going to be like way down here or even further. We'll just estimate. Okay. Then we have -1, -16. Again, it's going to be way down here. 0, -8. 1, -4. 2, -2. So our graph is going to look like that. Now we need to take each of those points, though, and move them left 3. So yeah, for the ones that are off the graph, it might look a little funny to do that. So just every point we're moving left 3. So now our graph will look like that. So is this exponential growth, decay, or neither? Well, because our a value is negative, this is neither growth nor decay. Our domain, -infinity, infinity. The range. Well, the y values are going all the way down to -infinity, and they're approaching 0. As we don't have a vertical shift, so the y values are getting closer and closer to 0. Horizontal asymptote, well, we know that it should match with our range. And then end behavior, as x approaches -infinity, well, the left side is going down, so y approaches -infinity. And then as x approaches positive infinity, well, the right side is heading towards that asymptote, so y approaches 0. So again, you'll see our range, our asymptote, and our end behavior all have that 0 in common. All right, down here, we're going to write some equations based on the information given to us. So number 4 says create an equation of a function that represents exponential decay. All right, so this means that b must be less than 1. It says it has been translated left 9. Okay, so that means if it's been translated left 9, that means our h value is equal to -9. And up 6 means k is 6. A hidden piece of information is that because it says exponential decay, that means our a value is also positive. Because, as we saw just in this graph up here, if your a is not positive, you don't have growth or decay. So in order to have exponential decay, we must have an a value that is positive. So anything else, we are free to decide what we want to do. So y equals a positive a value. Now it just says exponential decay. It doesn't say what our b value has to be. Our b value just has to be less than 1. So we can do 1/3. As raised to the x. Well, instead of writing x minus 9, because that's our h value, the function, the standard form of our function would say x minus h. And because our h value is negative, that's going to be x plus 9. And then we'll have plus 6 on the outside. So this is what our function could be. It might help us to write this on the top so that we know where to plug things into with our formula. All right, number 5 says create an exponential function that has a parent function of y equals 2 to the x. So that means our b value has to be 2 because it says 2 to the x. It says has a horizontal asymptote at y equals 5. Well, what that means is that our k value, our vertical shift, must be 5 because we're shifted up 5. And then it says a vertical shrink. Well, vertical shrink just means that a is less than 1, but it's also positive. Okay. So now we can write out that equation. So y equals, well, a has to be less than 1, so let's do 1/4. And then we'll have 2 to the x power. There we go, times 2 to the x power. And then plus 5 on the outside. So this is our function. That 1/4 could be any fraction. You could have 2/3, 5/7, anything like that, as long as it was a positive number but less than 1. And then in number 6, it says create an exponential function that has a parent of y equals 5x. So again, that means our b value is 5. Has a range of y is less than 3. That tells us a couple things. Because the actual number is 3, that tells us our k value has to be 3, because that means we got to be shifted up 3. But because that part says y has to be less than 3, that means a has to be negative in order for us to have all those numbers less than 3. If we look at this right here, look at the range for this function, -infinity, 0. So all the y values less than 0 are in the range of this function that had a negative a value. So that we have to account that a is negative. And since it's a vertical stretch, that a value is greater than 1. So we'll have y equals -7, that's a negative value for a, times 5 to the x power. We don't have a horizontal shift, so I'm not going to write anything there. And then k is 3, so we have to have plus 3 on the outside. Okay, so the only thing that could have changed in this problem, you could have had a different negative number in front. You could have -12, -4, anything like that, and you still would have been okay. So I hope that this was a good extension from what we did the other day, kind of taking what we did there and pushed it a little bit further by shifting left, right, up, and down. For writing these equations, I think doing what I did where I color-coded things and wrote down what that meant, I underlined something in blue, and then over on the left, I wrote in blue what that meant, what information that gave us. So I think you will find that extremely helpful. So thank you for watching. Make sure to smash the like button and subscribe.